Electrical impedance spectroscopy EIS, of electrodes modified with PEDOT:/PSS-Reduced graphene oxide composite. Electrochemical impedance spectroscopy, EIS, is a powerful technique used to characterize the electrochemical properties of a systems by measuring their electrical responses over a range of frequencies. It involves applying an AC, alternating current, signal to the system and measuring the resulting response in terms of impedance. The impedance is measured usually as a function of frequency and is represented in a Nyquist plot. In this case study, it involves the use of EIS techniques to study the electrical behavior of electrodes that have been coated or modified with a composite material consisting of PEDOT:/PSS and RGO. The SPCE was connected to a potentiometer, and the signal obtained was processed for further analysis. On the fabrication of RGO-PEDOT:/PSS electrode, 500 L of PEDOT:/PSS was mixed with 500 L of UHCGO solution in a small vial. The solution was stirred using a magnetic stirrer and sonicated at 30 degrees Celsius for 10 minutes to obtain a homogeneous mixture nanocomposite. A 3 LGO-PEDOT:/PSS mixture was drop cast onto the working electrode of an SPCE and left to dry at ambient temperature. The electrode was reduced using a potentiostat via repetitive cyclic voltammetry for 15 cycles. It was ensured that all electrodes, WE, RE, and CE, were fully immersed in the PBS during the reduction process. The reduced electrode is rinsed with DI water and dried at ambient temperature for 2 hours. The reduced electrode was dipped into a cell that was filled with 5-MkFACN6/K4FACN6, 1:1, in 0.01 mpbs. It was ensured that all electrodes were immersed in the solution. This measurement was conducted following the conditions. The obtained data of real impedance versus imaginary impedance from the EIS measurement were observed and recorded. To compare the results, the above steps were repeated with a bare SPCE electrode. This figure shows the Nyquist graph comparing impedance measurements of SPCE and RGO-PEDOT:/PSS/SPCE. The impedance for the reduced electrode is higher than that of a bare SPCE, indicating increased resistance at the electrode interface. The Nyquist plot typically shows a semicircular region at low frequencies and a linear plot at high frequencies. For the bare SPCE, the dominant feature is the linear region, suggesting electron transfer influenced by a diffusion-limited process, represented by the Warburg impedance, ZW. In the case of RGO-PEDOT:/PSS/SPCE, the linear region is slightly shorter, and a small semicircle is observed at low frequencies, indicating reduced influence of the Warburg impedance. The results suggest that the RGO-PEDOT PSS/SPCE electrode exhibits a slightly capacitive behavior, likely due to the presence of polymer PEDOT PSS in the electrode interface. That's all from us. Thank you for your attention. The attached link is the references for the case study.